This is a hard problem. Uh, it's the employee free time problem. And I'm not going to bother reading all this, but basically you have these schedules for different employees. This is one employee schedule, another employee schedule, a third one. Find the free time in that they have, like in common. Same here, you have three employees. These are the different schedules on the calendar. And the objective is to find the free spaces between their schedules. That's all there is to it, really. Um, so for example, we can walk through this quiz. You can pause and try and answer it. I see. This is one employee schedule, I think. How does this work? Yeah, this is one employee. Um, this is another employee schedule. There's another employee schedule. It's hard to see. It's easier to see when you have it here. So I'm not gonna bother with any of these quizzes. Um, and I will just show the solution here. Make a heap, push the first interval into the heap. Previous interval is the start of the first. Pop the smallest interval from the heap compared to the previous interval. If the current starting time is greater than the previous, update the previous interval as the maximum of the previous and the end of the current. Okay, it's a lot of stuff, and you can't understand the problem by just reading this. It's better to step through the code, really. And if my internet will let me, we will do just that. Okay. My internet will let me, we will do just that. Next, we'll look at the solution. This steps through the solution, and you can pause and read some of this, but I think you gain more by just watching what happens here. So we have two employees, right? These are their schedules, like start and end time, start and end time, start and end time, start and end time, and it looks like this. So we know that there's a free time over here, right? Between 4 and 6. Yeah, between 4 and 6, that's it. That's the only free time there is. So we know we want 4 and 6. Take the schedules to start time and its index and start value 0 and create a minimum heap. So we take this employee A, we say his index is 0, his start time is 2, and this index for his first interval is 0. So that's why we have 2, 0, 0 here. Same, this employee O1, because we're counting from 0. So he's employee number 1. He has his start time is 1. Actually, his start time is 1. He's employee number 1, and this first interval that we're talking about is indexed at 0. We have a variable called result that stores what we're going to return, and then we keep another variable called previous. It's the start time of the first interval in the heap, and it's a minimum heap. So every time you pop something from the heap, you will get the smallest value occurring at that point in time. So, we will look at the code shortly, but you can step through this and see what's going on. It's super complicated. I don't think a video does it justice. You have to run it more than once in your head. And on paper, actually, you have to look at it. We keep I and J as cursors. They move through the employee index and the interval of whatever specific employee, because we're going to be hopping between different employees, and we're using I to do that. So, and when we hop between employees with I, we use J to track what employees interval we're dealing with at that point in time. And so we've added these to the heap. We've done quite a few things. When we see, so this is the heap currently. So the first thing you do in the loop is to pop something from the heap. Now we've popped this 110, which represents this interval over here, and it's employee number 1, right? Not employee 0, employee 1. It's his index at 0, his first index. So we select the interval there, push the current employee's other interval as a start value. As the start value, it's indexed. So push this one next. Before we only had the first intervals of all the employees in the heap. Now we've popped this one, so we're adding the next one for that specific employee back to the heap. Um, uh, since the selected interval, since 1 is not greater than previous, because previous was 1, it's not greater, so we don't store anything to the array. Set the previous as the maximum of the previous interval and the selected interval's end. So maximum of 1 and 4. So set the previous as 4. And so on. So now we've popped something else. We've popped 2, 3 was next, right? Because 2 is here and it represents this one. So we're going to pop that next. And since we've popped this, we know that's employee 0. So I is 0. We know it's the 0th interval for employee 0. So J is 0 as well. And so we select that interval for comparison. Since 2 that we popped here is less than 4, we don't add anything to the result because it means there's no free time. It's actually overlapping. And then since 4 is still bigger than 3, we still leave previous as 4. So do it again. Now we're popping because this is how the heap looked, right? So now we're going to pop this guy out, which represents this guy. So pop it. It was employee 1 and his index 1 0 1, right? Employee 0 1 and 1. So we said I is 1, J is 1. And since the start is bigger than 4, we add 4 and 6 as an interval to the result. Remember, from the beginning, let me expand this. From the beginning, we knew that 4 and 6 was the answer, right? So now here we are evaluating this. We get 4 and 6. We set previous to the end of the current interval, the maximum of the current interval in the previous thing, which gives us 7. Then we pop this last thing in the heap. It's the last thing in the heap, so the heap becomes empty. It represents employee 0 and the ith index of his work. So, and 7 is not greater than the previous, right? It's not greater than 7 because the previous was 7. So we don't add anything to the result array. Set the previous as the maximum of 7 and the intervals end 9. And since we are done with iterating through the heap, we can return result. We're done. And that's it. Next, we'll look at the code, the very, very complicated piece of code. We can step through the time complexity before we go on. So it's O of n log k, where k is the number of employees and n is the number of intervals. So as number of employees approaches infinity and number of intervals approaches infinity, it behaves this way. Because a heap can contain a maximum of k elements. The heap can contain a maximum of k elements at any point in time. Space complexity is O of k, so the space you need grows linearly with the number of employees you have. Yep. Also, we're using a modified minimum heap for this solution. Prior to now, we only stored pure numbers in the heap, but now we're storing like an array that contains some interesting things. The array is made up of basically this: an interval start time, the employee index, and the intervals index for that specific employee. As I mentioned earlier, this is a hard problem to step through. So let's just see how it works, how it's similar to that diagram. So we have a minimum heap we're creating. We seed it with the first slot of each employee with this. So you're just adding the first the start, the current employee index, and the index um of their meeting. So basically, the first index, we're just storing this in the heap first of all, and then on all this code is available on GitHub. We take the first one, right? We peek, we don't pop. The first one, interval of start, employee index, and interval index, in which case would be this for us, right? And that represents this employee, employee B, because he has the earliest start time. As we can see here, he has the earliest start time. So the heap just helps us keep track of what's earliest across all intervals. That's what it does, essentially, because we know this is sorted, right? It's part of the requirements for the solution. And so that's what this does. Our result array that we're going to return, and we begin the work. So we peek, take the very first one, that's this one, this guy over here, represented by this. Remember, this is the employees index, because this employee B is employee A is index 0, employee B is at index 1. Then we're dealing with his first value, his start value. Actually, the start value is here. His index is here, and the interval we're considering, interval 0, his first interval is here, and that's what we're doing over here. We set previous to the start value. So previous is going to be 1. That's how we get 1 the first time. And then while there's still something in the heap, we do what we just stepped through. Only this time we're pulling, and pulling is the method in the minimum heap where you take the value out. So this is the employee index, this is the interval index, and this is the start time, interval start time. Yes, the interval start time that we're considering. Select the interval with I and J, do those things we did prior, check if the start is bigger than the previous, which happens for the first time here. If the start is larger than the previous, then take the interval, create a new interval, the previous and start, and push it to the results. That's how we got 4 and 6 here. And after you're done with that, update previous to the maximum value between what was there before and the current interval's end time. If there's any other interval in the current employee schedule, push that onto the heap. And that's how we move on to the next schedule, because in the beginning we only took these in. That step helps us move to a different interval to consider. So yes, and because it's sorted, we know that we sorted in ascending order. We know that whatever's next is actually the earliest time. It's always the earliest time. We're always evaluating from the earliest to the latest time. And that's how you get your result. Thank you for tuning in. See you next time. An educative day keeps unemployment away. Ciao. Like, share, subscribe, leave a comment. Much appreciated. Bye-bye.